Hi everyone, this is Huang and my final project focused on estimating the force and torque with our force and torque sensor based on Python system. Recently, a force torque sensor costs $5,000 each, so I'm finding a potential solution to estimate force and torque without a sensor in acceptable area. That would save a lot of money. In this project, multiple packages in Python will be used. The best solution for this would be robotic system toolbox package. However, I'm not sure why I have problem to import that, so I use SciPy for the substitution, and that also works. The first step is to build up a robot arm model like this. In this code, I set up with mass, center of mass for each link, increaser, as well as homogeneous transformation for the robot arm, and now try to run the code. Then I get the joint position over time for 3 motors in 0.1 second. The next step is set up the PID controller for the motor, and here is the PID gains for each motor. In the simulation, I can see joint 2 and joint 3 is adjusting gravity by PID controller. Then the next step is starting to implement the range observer, and this is the working process of it, and this is the equation. Then implement the observer in the code, set up the observer gains for each motor, then set up the external force simulation from 1.5 second to 3.5 second toward down, as well as the calculation of the observer, and also set up with the plot. Then this is the joint position for the observer simulation. And this is the estimate external torque on the simulator. Finally, I will run my observer in my actual motor arm. So first step, setting up the basic parameters to the motors, and then using the Dynamics SDK package to convert all my calculation and the control signal and send to the motors. Finally, I got the estimated external torque at end-effector a long time. I applied the force toward down at around 5 seconds and remove the force at around 8 seconds. In summary, the Python-based system for range estimation has successfully built up. However, there is still way to go. For example, the result output is oscillating so much when it don't have any external force applied. So that is a thing I need to work on later as well. Momentum-based observer is not the best solution for this problem. I will still need to explore more solutions like extend Kalman filter observer or even some brand new solution like machine learning. That's all for my project. Thank you for your listening.